Hello and greetings to everyone. Today we are to treat the base units and derived units. We take the first one by the margin I. We have base units. When we talk of base units, these are units which are used to define other units. That means they are used to define other units. These units are used to measure base quantities. There are 7 base units as shown on the table below. There are 7 of them. Okay, let's represent this on the table. The first column carries the physical quantity. The next column carries the base unit, while the next column carries the symbol of the unit. For the first one, we have length. It has a base unit meter which has symbol lowercase m. Next one we have is mass, which has base unit kilogram, and it has a symbol kg. The next we have time, which has a base unit second, and the symbol is lowercase s. The next we have temperature, which has a base unit Kelvin, symbol uppercase K. The next we have current, which has a base unit ampere. It has a symbol uppercase E. The next we have the amount of substance, which has a base unit the mole, and it is represented by mole like this without an E. The next we have the luminous intensity. Luminous intensity. It has a base unit the candela, which has symbol CD like this. You can see these are the 7 base units, we take note of their symbols and the physical quantities. Next, we look at the derived units. Take 2i, derived units. When we talk of derived units, these are units defined in terms of base units. That is, they are expressed as combinations of base units raised to certain powers. Take these derived units are used to measure derived quantities. In bracket, quantities whose measurement depends on the measurement of base quantities. Then we note this down. It's very important. The first one, units which are names, that means they are names of persons, always begin with a lowercase letter. E.g. is an example, Newton, which is the unit of force. Another one is a joule, which is a unit for energy. Take the next hyphen. The symbol of a unit which is named after a person is always an upper case letter. Okay, take for example like the Newton, representing it as a symbol, we make use of capital N, uppercase N. We take the next hyphen. For convenience, comma, some derived units which are relatively complex, that means they are very long, which are relatively complex, are given special names. Next hyphen. SI units are uniform, that is independent of the location where the measurement is done. If we take this down, the table below shows some derived quantities and their units of measurement. Let's draw the table. It has 3 columns. The first column carries the derived quantity. The next column carries the name, in bracket the symbol, that means the symbols are represented in the brackets. Then we have the base units. You see the base units are raised to certain powers. We take the first one. We have force. The name we have a Newton with symbol uppercase N. The base unit we have a kilogram, meters per second squared. Next we have energy, work, heat. These derived quantities, they all have the same unit of measurement, which is the joule with symbol uppercase J. Then the base units we have a kilogram, meters squared per second squared. The next we have power, radian flux. They all have the same unit, which is the watt with symbol uppercase W. Base units, we have the kilogram, meter squared per second cube. The next we have electric resistance. It has a unit, the ohm, with symbol. We have the omega like this. Then the base unit, we have the kilogram, meter squared per second per ampere. The next we have a pressure. It has a unit, pascals, with symbol PA like this, which stands for Pascal. The base unit, we have a kilogram per meter per second squared. These are some derived quantities with their units, base units of measurement. If in case you have any questions on what we have just done, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. You stay tuned for our next lesson, which is on dimensions.